8.5, solving proportions using cross products. All right, we should be on page 394. I see books for most everybody open. Let's get our books open, page 394. Okay, yesterday we learned two methods of solving proportions. Okay, we learned how to solve proportions using equivalent ratios to find the missing link between the numbers. We also learned how to solve proportions using algebra to multiply by the reciprocal. Well, there's a third method that we can use to solve a proportion, and that's using the cross products property. Okay, this property tells me that I can multiply the numbers across from each other, the ratios, okay, I can multiply them to find the answer to the unknown variable. So now I have 2 times d, which is 2d, and 3 times 9. I make them equal to each other. Then I want to evaluate 3 times 9, so I get 2d equals 27. Divide both sides by 2 to solve for d, and d equals 13.5. Okay, now notice the second example, I have some decimals, but the way that I solve this does not change. I want to use my cross products, all right, and multiply them. So I have 2.2 times 11 equals 5.5c. Now, make sure whenever you're writing your new equation that you use parentheses to show multiplication, or if you're multiplying a number and a variable, just write them right next to each other. I don't need parentheses around the variable. I definitely don't need a little x or a dot. 5.5c is how I show multiplication. Now, this takes me back to chapter 7. How do I solve for the variable? Well, I need to divide both sides by whatever number is attached to the variable. In this case, it's 5.5. Okay? Well, what's 2.2 times 11? Anybody know?
Will you use my calculator?
Yes, absolutely. You can use your calculators. 2.2 times 11 is 24.2 divided by 5.5, which that will equal c. And c equals what? What's 24.2 divided by 5.5? The answer is 4.4. C equals 4.4. And that is how I use cross products to solve. When you do your homework tonight, this is the type of work that I want to see. Obviously, you don't have to use colored pencils. Okay, you can write it all in using your pencil. But this is what I want to see, that you circled your cross products in the original proportion, that you wrote your new equation, and then you solved for the unknown variable, which you all know how to do because that's from chapter 7. Now, in example 2, it gives us a word problem, and we have to write and solve the proportion. So it tells me that a person weighs 105 pounds on Earth and 17.5 pounds on the moon. And then in comparison, a dog weighs 60 pounds on Earth, but we want to know how much it weighs on the moon. Now, why do you think we used a W as our variable?
Weight.
Because I'm looking for weight. Okay? Now, does it matter what variable I use? No, it doesn't. Okay, as long as the variable is in the correct place. So, would this be how I write my proportion? 105 over 17.5 equals W over 60. Is this correct? Is this how I write it? Am I comparing the same unit in my numerators? This is 105 is the weight on Earth. Is W the dog's weight on Earth, according to the table?
No.
No, it's the dog's weight on the moon. So in this case, this is not a true proportion. Because in order to write a true proportion, I have to compare the same unit on both numerator and denominator. So now I'm comparing weight on Earth for a person to the weight on Earth for a dog in my numerators. And then in my denominators, I'm comparing their weights on the moon. Okay? So now I have set up a true proportion. I can solve this using my cross products. So 60 times 17.5 and 105W. Okay? So now I'm going to write my new equation. 105W equals 60 times 17.5, 105W equals 1050. I want to divide both sides by 105 to solve for W. And my weight, W, is going to be 10 pounds. All right, in example 3, again, we're writing and solving a proportion. But this time, I have an added step. Let's read the example together on page 395. Sean, I said 3 times, open your book, page 395. Okay? All right, example 3. It says, at an aquarium, the ratio of rockhopper penguins to African penguins is 3 to 7. So rockhoppers to African is 3 to 7. Okay, if there are 50 penguins, how many are rockhoppers? Well, the first thing I need to figure out is the smaller ratio. It says that for every 3 rockhoppers, okay, there's 3 rockhoppers to 7 African. Well, how many total penguins is in the smaller ratio? 3 rockhoppers and 7 African penguins. How many is that total in that small ratio? It's 10. And out of those 10 penguins, how many are rockhopper? 3. So my smaller ratio is 3 over 10. So I had to do a little bit of adding there. I know that rockhoppers plus the African make up 10 penguins total. And out of those 10, 3 are rockhoppers. So that's my smaller ratio. And now it wants me to figure out how many rockhoppers are there out of 50. So that's going to be my larger ratio. I can solve this using my cross products method. Okay, so I have 10R equals 3 times 50. Now I have 10R equals 150. Now how do I solve for R? Divide both sides by 10. And R equals 15 rockhopper penguins. And make sure anytime it's a word problem that you label. Okay? So this one was a little different because I had to figure out what was the total number of penguins in the smaller ratio. Okay? So I had to do a little bit of adding there before I could set up my true proportion. All right, one more example. If I'm given 2 ratios, how can I tell whether or not they form a proportion? Well, I can tell by making them both equal to each other. 24 over 104 equals 3 over 13. I can use my cross products method, 24 times 13 and 3 times 104, to see if they actually equal each other. Well, class, what's 24 times 13? Go ahead and put that in your calculator. Nope. 20. Very good. It is 312. And what is 3 times 104? Nope. 3 times 104. 312. So since I used the cross products property and I found that both sides did equal each other, is it a proportion? Yes, it is. Yes, it is, because both sides equal each other. So that would check out, and I would say yes. All right, this is just like numbers 28 and 30 tonight on your homework. If you understand this, this is everything you need to know for 8.5.